the recording is on now. All right, and I have two questions on my screen, and hopefully you are all able to see it. The two questions are, what is refactoring and why do we do refactoring? I was not hoping that chat is going to be an option in this particular meeting, but then now that it is on, you guys can, I would still appreciate if you can unmute yourself and then try to make this an interactive session where you guys are actively contributing to these questions and the discussion. All right, so two questions for you guys. One, what is refactoring? And two, why do we do refactoring?
So, hi, this is Manish. I'll pitch in.
Hi, Manish.
Why do we do? Yeah, at times when you're writing code, to let's say make something work, you might not write the best possible code which is maintainable, and this will collect over time. So there comes a time when you realize that probably we need to improve the quality of code. So how do we do that without changing the functionality in any way? We restructure the code or change things around, move things internally, or change the structure a bit. That is called refactoring, and so that it becomes maintainable over a long time, easier to understand. That's why we do it.
All right, that is an excellent answer. Thank you so much, Manish. So refactoring has at least two purposes. That the application that we started with is not the application that is probably production ready, that is probably not performing the operation the best possible way, and there is still room for improvement. But we already have a copy of the application, a product that is sellable, shippable to the customer, which works fine. Now, software industry is the only industry where we can change things after they are in production. It is unlike any other industry. Take for example a production industry where you have a car manufactured. Once the car is out of the factory, that is it. It is very difficult to make changes to that application. Software industry is a little different. When we develop application, it is doing some functionality. Even if it is dirty code, that is fine. All right, we can get it to be used by developers and engineers, right? But we still have some room of improvement as they are using our production copy of the application, and this is where refactoring comes in picture. And like Manish said, one of our objectives of refactoring is to not break an existing functionality of the application. All right, so this is the general life cycle of an application, that there are going to be some requirements. We start with requirements, and then a team of analysts and BAs and technical architects, they sit together and analyze and design a software. Then developers and QA folks pitch in, and then they do software development and testing. At one point, when the product is stable, shippable, it gets to a phase where we are maintaining that application. Now, maintenance is a little challenging. Adding new features is difficult. Fixing defects is difficult. And it is more difficult when your code is not the right quality. Do I hear somebody? Alright, no worries. So maintenance is a challenging phase of an application. And it is challenging when your code is not the right quality. With the agile methodology, things have changed a little. The product development or software development lifecycle of the waterfall was a little slow because it was taking place in stages. By the time the product is out in the market, ready to ship, a lot of time had already passed, and a lot of design decisions that were true probably when they were designing the application, they have changed too. With Agile, we have changed that methodology. Now we say that I want to create a smaller piece of application, and then when that application is ready, I'm going to take it out to the market, and then the end user will be able to use it. The advantage of doing this is we can fail early, and we can identify what are potential defects in the application. Now, one of the things that Agile advocates is that every 10th iteration, you should save for cleaning up the technical debt that you have created. A technical debt is a situation of the code where things are working, but then they are not the best possible design. And to improve that design, we apply the refactoring rules and principles. All right, and through that we improve the software. So here is the first answer, that refactoring improved design of the software. It makes applications extensible and maintainable, and it is easier to make changes and improve the understanding of the software. Now, one more question to you guys. Who do we write software for?
Customers.
Okay.
Users.
All right. Any other answer? This is
for the computer.
For the computer. Not exactly, because see. Okay. Let me put the question differently.
We also write software for ourselves, our future selves, and our team members who are going to work on the software in the future.
All right. So this is the answer that I was expecting. Probably I did not put the question the right way. How do we decide that we want to use a particular language, right? Because a software written in machine language, probably in assembly language, probably in any other lower level languages, is also a software, right? I can write a C program that probably displays the same web page that an ASP.NET MVC application can display, correct? But the way we pick up technologies is not for computer or for customer, because our customer would anyway be happy as long as they are able to see that web page. They are fine, right? They don't care the technology in which it is written. As long as the end user is having a working application in their hands, they are fine, right? One of the audience of the code that we write is the fellow developers, probably who is sitting next to us. And our objective as we are developing application and writing code, we should look at our neighbors who are sitting next to us and try to create a software, try to create a code that they will be able to understand at a later point in time. All right, so that was the answer that I was expecting. Thank you, Manish, once again. Moving on. All right, so refactoring is actually multiple tools and techniques that we apply to improve design of software. Now, what are those tools and techniques? Probably renaming variables, probably moving feature to new file, moving code around so that a code has a better house, a better place to sit where it logically belongs. Removing that code, applying design patterns, adding entity framework, things of that nature, they all together constitute the refactoring tools and techniques. The objective of this exercise is that we take the code to a level where it is more understandable. Now, Martin Fowler has a phenomenal book on this subject, and it is exactly by this title, Refactoring, Improving the Design of an Application. So he has, in the first chapter itself, he has defined the term refactoring in two English terms. The first is a noun, is that a change to software, and refactoring as a verb is the action where you are restructuring the software. So in this session, we are going to apply the techniques that were listed here and some more techniques, and improve the design of the code that of which link I shared with you guys. Excuse me. All right, to apply those refactoring techniques, one technique that we are going to use are the solid principles. Now, I am pretty sure that all of you are familiar with the solid principles. Each of this letter stands for one of the principle. Like the single responsibility, you should have one class. The open close principle, it says that your application is open for extension and closed for modification. Now, extension is a pretty big term. Extension, the way I understand extension is that you should be allowed to replace one functionality with another. And then my inspiration for understanding open close principle is generally the electricity in the house, right? The guy who designed electricity, they only worked on delivering electricity to your doors through the electric socket, but then they left us free on as to how we want to consume it. We can charge our phones, we can charge our computers on an electricity circuit or electricity delivery mechanism that was created back in probably 18th or 19th century, right? So this is a great way of understanding extension, that we design a software that can be consumed or extended into the future in technologies that are probably not even imagined at the time of development of the software. The next in line is the list cost substitution principle, and it says that if there are two types that are derived from the same parent, we should be able to replace those types. The interface segregation principle is a little bit like the single responsibility principle, but then it is applied to interfaces. And it says that we should write smaller interfaces that are logically grouped together and that are part of one single functionality, so that a client that is implementing these interfaces does not become a heavy client and ends up creating functionalities that it does not require. The last in line is the dependency inversion principle, and it says that we should really code against abstract classes and interfaces and not against concrete classes. All right, so with that, let's jump to the second section of the application. I shared a link in the morning, which was the code that I'm going to use in this solution, and I requested you guys to probably take a look at that code and probably think as a technical reviewer and share your feedback as to what you think. So we are going to do that exercise in a very short time. The link is here on the screen. I have already gone ahead. There's a link called get the code. I have already gone ahead and downloaded this code, and I have it open inside Visual Studio. All right, there you go. It is right here. All right, so once we get this code to working, all right, we're going to start with the application walkthrough. This is where you're going to pitch in again and you're going to tell me the things that are wrong inside this application. We'll require a database. I have SQL Server 2019 installed and running on this computer. As a first exercise, I'm going to bump up the .NET version from the code is actually built for 4.5. We are going to bump it up to 4.8. That is going to break a few things. Not exactly that is going to break a few things, but then there are a few packages. Once we update those packages, a few things are going to be broken, and then we're going to fix that next. All right, so let's get